The title of this lesson is Applications of the Electromagnetic Spectrum. Now, if you need to pause the video at any point to write something down, please do so. So first of all, we need to know the order of the electromagnetic spectrum. We have radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Now you can remember these by brute force, by simply repeating them over and over again, which is what I did when I learned them in my GCSEs. However, there are some mnemonic devices that you can use, such as creating a story. Now the crazier the story is, the better. So you can link each of these to a different object. Let's start with a radio. Imagine that you put that radio inside a microwave. That microwave starts to glow red to represent infrared. It then melts and turns into an eyeball to represent visible light. That eyeball is ultraviolet, and so it gets into a fight where it breaks its arm, and so it needs an X-ray. Then, during that X-ray, they notice that inside its stomach is a large piece of gammon. Now the story is strange and ridiculous, but that's a good thing, because the more strange it is and the more ridiculous it is, the easier it will be to remember it. Now you can come up with your own story, or you could come up with another mnemonic, whichever is easiest for you. So let's look at the frequency, energy, and wavelength. Radio waves are the lowest frequency, lowest energy, and longest wavelength, whereas gamma rays are the highest frequency, highest energy, and shortest wavelength. So write down a table in your books with applications and then the different parts of the electromagnetic spectrum. We'll start with radio waves. Radio waves are used in satellite communication, where we have satellites orbiting the Earth, sending and receiving radio waves to communicate. We have radio broadcasts. The radio itself is named after radio waves. Television broadcasts also use radio waves. Televisions originally were just advanced radios. And radar. Radar stands for radio detection and ranging. What happens here is a radar dish sends out radio waves which reflect off objects and return to the dish and are detected. This allows a radar dish to locate objects in the sky. Next we have microwaves. The first and most obvious is for cooking food. Microwave ovens were named after microwaves. In fact, it was discovered by somebody who was working on a microwave dish. They happened to notice that some of their food started to melt. That same day, they then filed for a patent on an oven that would use microwaves to cook food, and named it the microwave. Microwaves are also used in satellite communication, and they are used in mobile phone communication as well. However, remember that the strength of those microwaves is much, much lower than those in a microwave oven, and they use slightly different frequency ranges, which means mobile phones do not heat anything with their microwaves. Infrared. Again, we have cooking food. Infrared is the same as thermal radiation, and so you can use infrared light to heat objects. In this case, we have a hob which is producing infrared light, and that will heat the pot or the pan that's placed above it. Thermal imaging. It turns out objects glow in infrared light. So if you can see that infrared light, you can see them glowing. The higher their temperature, the brighter they glow. Night vision. Now this is different from thermal imaging. In night vision, a torch is used, which sends out infrared light that is invisible to humans, but a camera on the headset can see that infrared light, and so therefore whatever the torch is shining on can be seen by the wearer. However, that light is invisible to other animals and to humans. Fiber optics. Fiber optics are very thin glass fibers. Infrared radiation can be sent along these fibers for communication. This is used for the internet and also for military communications. Visible light. First of all, we have the obvious one, sight. We call it visible because it's the one that we can see, which is slightly arrogant because other creatures can see different frequency ranges. Butterflies and reindeer, for instance, can see ultraviolet light, and so we call it visible light simply because it's what we can see. Photography. Images can be recorded using visible light. Microscopy, where visible light is magnified by lenses to see small objects. Telescopy, where light is magnified by lenses to see distant objects. And finally, fiber optics. Visible light is also used in fiber optics to send signals along these tiny glass fibers. Ultraviolet. Now, ultraviolet light can be used to detect forged banknotes. This banknote is real because we can see that there is an ultraviolet fluorescent dye. Now, what happens is, when the ultraviolet light shines on this note, that dye absorbs the ultraviolet light, but then re-emits light of a lower wavelength. That wavelength can be seen by the human eye. Tanning beds. Ultraviolet light is what causes us to become tanned. It's also what causes sunburn and skin cancer. You can sterilize water using ultraviolet light because it kills bacteria and destroys viruses. So in many water treatment plants, they will have ultraviolet lights. X-rays. X-rays can be used in medical imaging to detect broken bones. That is because X-rays pass easily through the skin, but not so easily through those bones. In fact, it is refracted by the bones, and so we get this image. The medical imaging of intestines involves either drinking or using an enema in order to insert barium sulfate into the lower intestine, the large intestine. This makes it opaque to X-rays, and so we can see an image of the large intestine thanks to the barium sulfate that's inside. CAT scans. CAT stands for computer-aided tomography. These are essentially three-dimensional X-rays. They can produce a three-dimensional image of the entire structure of the human body. And fluoroscopes. Fluoroscopes can produce real-time images. So if surgery is being completed, then you can see inside the patient using a fluoroscope as the surgery is being done. However, this is very rare to do due to the effect that fluoroscopes have on the surgeons. It can also, though, be used to observe body parts when they are in action, when they are completing certain tasks. Gamma rays. Gamma rays can be used to sterilize food because they kill all living organisms. So if you've ever had a tin of food, like some tinned peaches, these will have been treated by gamma rays in order to kill any bacteria inside that tin. Sterilizing medical equipment. Again, gamma rays can kill all living creatures, and so they are used to sterilize medical instruments. And finally, irradiating tumors. Gamma rays can be used by focusing several different sources of gamma rays onto one single point. That way, if you look at the image, most of the brain only receives a small amount of gamma rays, but there is a point inside the brain where there's a tumor where all of the gamma rays cross over at one location, giving a very high dosage of gamma rays to that location. And medical imaging. Blockages in organs can be found by injecting radioactive materials. So if you inject a radioactive material into the blood, you can observe the circulatory system, or you can observe where that radioactive material builds up. Now, these radioactive materials decay, and when they decay, they produce gamma rays. So you can see where those radioactive materials have built up inside the body.